Reaching for the stars, the power of rocket fuel. Space exploration is a fascinating journey into the great unknown. But to get there, we need a powerful force rocket fuel. Rocket fuel is like the special juice that helps rockets break free from Earth's gravity and travel vast distances in space. Without rocket fuel, we would be stuck on Earth, only dreaming of distant planets and stars. Different types of fuel have been used throughout history, each with its own strengths and weaknesses. These fuels have allowed us to launch satellites, send humans to the moon, and explore the outer reaches of our solar system. Understanding rocket fuel is key to understanding how we explore the cosmos. The quest for new and more efficient rocket fuels continues to drive innovation in space exploration. As we set our sights on even more ambitious missions, such as traveling to Mars and beyond, the right fuel will be crucial to our success. Solid fuels, the workhorse of early spaceflight. Solid rocket fuel is one of the oldest and simplest types of rocket fuel. It's like a giant firecracker, packed tightly with fuel and an oxidizer. The oxidizer provides the oxygen needed for the fuel to burn. Solid fuels are very stable and can be stored for a long time. They are also relatively simple to ignite, making them reliable for launching rockets. One famous example of a rocket that used solid fuel boosters is the Space Shuttle. The two solid rocket boosters attached to the sides of the Space Shuttle provided the initial thrust needed to lift it off the launch pad. While solid fuels are powerful, they have some limitations. Once ignited, solid fuels burn until they are completely consumed. This means rockets using solid fuels cannot be easily controlled or stopped once they are ignited. Liquid fuels, the powerhouse for giant leaps. Liquid rocket fuel is another type of fuel that has been essential for space exploration. Unlike solid fuels, liquid fuels are stored in separate tanks and pumped into a combustion chamber, where they are mixed and ignited. Liquid fuels offer more control over the rocket's thrust. The flow of fuel and oxidizer can be adjusted, allowing for more precise maneuvers in space. The Saturn V rocket, which carried astronauts to the moon, used liquid fuel. The Saturn V used liquid hydrogen as fuel and liquid oxygen as the oxidizer. Liquid hydrogen is very powerful and produces a very clean exhaust. This combination of power and efficiency made liquid fuel the ideal choice for the challenging journey to the moon. However, liquid fuels are more complex to handle and store than solid fuels. Section 4. Hybrid fuels, the best of both worlds. Hybrid rocket fuel combines elements of both solid and liquid fuels. Typically, a hybrid rocket engine uses a solid fuel and a liquid oxidizer. This type of fuel offers some advantages over traditional solid or liquid fuels. Hybrid fuels are generally safer to handle than liquid fuels and can be easily stored. They also offer more control over the rocket's thrust compared to solid fuels. Spaceship One, the first privately funded human spaceflight, used a hybrid rocket engine. It burned a combination of solid rubber and liquid nitrous oxide. However, hybrid rocket technology is still under development. More research is needed to improve their efficiency and reliability before they can be widely used for larger and more demanding space missions. The development of hybrid fuels represents a continuous effort to find the best solutions for space travel. Section 5. The future of space travel, a fuel-filled frontier. As we continue to explore space, the search for new and improved rocket fuels remains a top priority. Each type of fuel, whether solid, liquid, or hybrid, has its own set of advantages and disadvantages. Solid fuels provide reliability and simplicity, while liquid fuels offer greater control and efficiency. Hybrid fuels present a promising alternative, combining aspects of both. The specific requirements of each mission, such as the distance to be traveled, the payload weight, and the desired level of control, will determine the most suitable type of fuel. The future of space exploration depends on our ability to develop innovative fuel solutions that can power us farther and more efficiently into the cosmos. The search for the ideal rocket fuel is an ongoing journey, and the discoveries we make along the way will undoubtedly shape the future of space travel